Welcome to my seminar. My name is Toshifumi, as she introduced you. So I came here to show you some ideas about our technology. So I came from Japan, of course. I was a fellow researcher in the Yamaha Research and Development Center in Yamaha. So we focus on to the pro audio stuffs, not only pro audio stuff, but also the music synthesizer products. But I came here to introduce you a technology for pro audio mainly. So at first, I want to explain you about what kind of technology we have for pro audio stuff, like a digital console. What is VCM? VCM is abbreviation of the virtual circuitry modeling technology, VCM. So before I describe how it is, I want to explain about what kind of things is your musical demand in this industry. So digital recording is the key issue. Digital recording, digital reproduction of the music, this has pros and cons. Very accurate hi-fi recording and reproduction possible. It's very good. Also, nothing added and nothing lost. The quality of the high fidelity is very good in digital system, so the sound is very accurate. But too much accurate is not enough. It's not enough. Not only the accurate things, but the interesting sound, or fatness of the sound, or warmth. Those kind of things is very important for music production, music reproduction, for music playing, performance. Everything needs to have fatness, warmth of the analog gears in vintage era. I will show you an example. This is, you know, this very famous 4 persons and 1 woman. So this is Beatles. So Beatles produced their music in 60s and 70s. They used all the vintage gears. Of course, this is vintage era. So they used vintage gears like tube consoles, tube compression, very old analog tape recorder. Those technology, all the vintage technologies are key issue when we think about, we remember about those good era of music. So when we think about the same kind of musical goodness and bringing those kind of things into the digital domain, we have to take care about how we can emulate the sound of the analog music tonality in the digital domain again. So warmth and the fat sound of the vintage analog gears of the old era were demanded in digital domain as well in these days. So tube is the key issue. Everybody think about the warmth and the fatness represented by the tube or transformer or old era transistors. Those devices has a very, very character sound, having warmth and fatness. But we are now using the very modern technology. It's a digital DSP devices. Digital DSP devices is high power and very accurate. 32-bit processing, 64-bit processing, floating point, fixed point. Those kind of calculation, precise things are very important and very comfortable and very interesting, and they are very easy to use. But something lost. It's warmth and temperature of the hot temperature of the old vintage analog era. We need it in digital domain too. This is a basic demand of the music industry right now. We have a strength in this area. It's the VCM. When we explain about how we can introduce the sound quality of analog sound into the digital, we must tell you what kind of technology we have to emulate the analog quality or analog, so to speak, frequency band response or analog harmonics distortion kind of things in the digital domain, again, like we can get in analog domain. So this is one technology I can show you very easily. So macro behavior model is one of the methods to get analog sound in digital domain. Above, you can see the response in analog domain. This is the example of the peaking filter. And left-hand side, you can see the analog transfer response of the analog circuitry using a very, very common, very famous operation amplifiers. So capacitor, resistor, inductance, those devices are supplied in the analog domain. And the combination of these components can maintain some particular frequency response. This frequency response here should be realized same in digital domain too. Oh, sorry. Digital domain too. So the very great and accurate analog and the digital domain transfer response interpretation can happen. This is very straightforward and very famous and standard mathematical theory already investigated and already established in the mathematical domain, mathematical academy, so to speak. So everybody know about it. So any musical industry can use this technology very easily if you learn about mathematics seriously. But our strength is not this. Our Yamaha's strength is the component level emulation technology. For example, resistor here, where inductance is the center and the transistor right-hand side. Every component can be emulated in digital domain using our VCM technology if we need it. If it's necessary, we can dive into the component level transformation, or we can use a very standard mathematics to realize the same kind of frequency response in digital domain as analog domain. We can choose both methods. So this is our strength. This is one of the examples of the very famous Teletronics LA2A. This is very famous compression device. Utilize these tube devices, transformers, and also the opt device, EL electroluminescence, opt, and resistance converter equipped or applied on this Teletronics LA2A. It's very famous studio standard opt compression. And to emulate this circuit diagram in the digital domain, we must take care about circuit diagram first. Then this point, this stage is explaining you the this is opt device. This is opt device. Opt device is light and opt sensitive resistance combination device. Very old vintage device and tough to have in these days. But using digital domain technology, we can reproduce same kind of the behavior in digital domain using DSP technology too. So this is the opto device, and detect the sound level here. They introduced to the detection circuitry. It's a half wave detection, so to speak. Then feed the signal into the gain reduction controller. Then feed the signal again to the opto device. This feedback loop is the key issue when we talk about the immersion of the LA2A electronics opto compression. We can do that very exactly. We can do that very exactly. Not only the circuit level things, but also the behavior of the opto resistance device, as showed you, is very important and a very difficult part of this task. Left-hand side, you can see the electroluminescence light device, and the right-hand side is this guy. This guy is the optosensitive resistance. This combination can show you the sound of the opto devices. Opto compression is very smooth sound. This mainly came from this device. We can do this kind of the component level emulation in digital domain, using only in the music production area, but also the broadcasting, because any of the broadcasting have a limit on the final broadcasting amplifier part to limit the amplitude of the broadcast in a certain limited area. So this is the compression and the limiter for the broadcasting, any of the broadcasting system. So broadcasting guy knows about it, so we made it. Not only for the studio, but also the broadcast. It's a good application of this compression. Comp 369 is the name we put. So the classic transformer has like 254 compression, and the richness and the fullness of the transformer sounds introduced in digital domain using transformer emulation technology, using VCM technology. Smooth and natural compression happen. Also, we are now making some other VCM audio processing, like a multiband compression 4. This year, this device developed for the CL and QL updation, firmware update, 3 or 4. Multiband compression employed VCM technology to gain reduction circuitries like a VCM mode or opto device mode, like elevator electronics. And harmonic content control by harm switch is very interesting, very interesting. So again, it is not the simple digital domain 4-band compression, but also we introduce analog flavor using transformer emulation technology and VCM. And Reverge PM10 mixing console will equip this soon on newer latest firmware update. Anyway, as told you, the key is the VCM technology, and more essentially the transformer sound immersion in digital domain is the key issue when we talk about the great warmth and the fatness of the analog sound in digital domain. You can listen on our digital console. Transformer sound is a key. So we thought of another application of the transformer sound in the Yamaha console, Reverge PM10. It's silk. Silk as a switch and the control of the sound you can find on any of the Rupert Neve Designs hardware gears. It controls the harmonic content of the output of any devices like an equalizer or mic preamplifier and compression on the Rupert Neve Design incorporation products. So we introduced this circuit and the transformer of the Ruperto designs into our consoles, head amplifier for microphone preamplifier, head amplifier for the reverse PM10. Every channel have Ruperto Neves transformer sounds as a silk circuit. You can control the harmonic content using this texture knob here. This red knob is texture control. Texture adds the harmonics on higher area on red or lower frequency area on blue. This LED switch, you can change the color red or blue. And the red or blue individually control the higher frequency component harmonics or lower harmonics or individually. This is a diagram of the hybrid mic preamplifier for reverse PM10. Former part is a mic preamplifier and analog digital converter. And later, right-hand side, transformer emulation in DSP. And the seal circuit emulation here, you can control the texture when you tweak the knob of the texture and feed the information to the circuit in digital domain. So totally, this is an analog and digital hybrid head amplifier. Very good musical sound can happen, and you can control by yourself using red and blue frequency band control alternation using texture knob. How much you can get, you can control using texture. This is the texture silks part of the PM10. Okay. So final session with Rupert and Josh Thomas. He's the president of the Rupert Design Corporation right now. So another information, maybe it's also interesting for you guys. Channel equalizer for PM10. We introduced or developed and introduced the new channel strip equalizers for reverse PM10. So we already have a very good legacy EQ on the O2R or DM2000 or any of the CL or QL, M7, M9. Those all digital consoles has a very good digital equalizer. But we thought of we can introduce analog flavor or analog sound texture in the input channel also, like we can do on the plug-in effects too. So the precise type EQ and aggressive type EQ and smooth type EQ, all these three newer EQ types are introduced on the reverse PM10. Those are the precise. I can explain you how the difference between the three types. The precise type EQ is a successor of the legacy. So it involves the legacy EQ part of the precise type EQ. So it's the extension of the legacy EQ on the current modern days. And you can control the needs or rising points overshoots like this. You can see overshoots here. When you boost up the higher frequency energy, you will see the mid frequency slightly decreased or knee slightly emphasized. This is similar to the effect when you want to have sweet. When you want to have very good sweet, sometimes you add salt, but very low amount of salt. Or if you want to have very good salt taste, you apply very small amount of sweetness. I'm talking about the story of when you cook your sweetness or your foods. You know? So when you think about the salty things, how you can control sweetness is very important. When you want to have very good sweetness, how you can control the salt things, very important. But this is a very small part. So those shelves have the overshoots. This is very important to have another, counterparts, like a high frequency boost. You can decrease mid frequency to emphasize the high frequency. This is the very good influence, very good effects of the overshoots. When you apply very good overshoots on the higher frequency or lower frequency, when you design a very good equalizer for the consoles, this kind of balance control is very important, and the overshoots is that. So I talked a lot with reporting Eve. Mr. Reporting Eve knows how we can control the band control. Frequency band, overshoots control is very important. So in analog days, overshoots control role was very tough because analog devices are very poor when we want to control the nature. But nowadays, we can utilize the digital technology. So digital domain, you can control many things very precisely and very freely, So it means that we have very good strength when we use digital filter technology, digital domain technology, when we want to have very good analog sounding equalizers. This is a kind of contradiction, but reality. We can control very precise overshoots, a little bit more, a little bit more. Yeah, that's okay. This is very good. We can fix that parameter very easily. This is the goodness of the digital domain to emulate analog sound. Very interesting. Anyway, as a result, the precise has very good overshoots control. And you can control the overshoots by yourself to have the good strength of the slope of the high shelf or low shelf, or to have a more salt in the sweetness kind of things. You can do many things using precise. But somebody want to have very analogous EQ very easily, just choose this one, like a smooth type. You can get analog sound very easily. And aggressive is a kind of more aggressive type of analog sounding EQ. You can get very easily. So we have a very smooth analog sounding EQ and very aggressive type analog EQ on digital domain. So we made 3 types of equalizer on Reverge PM10. So this is an equalizer you can see. So silver is a precise. Silver is precise. This is aggressive. This is smooth. You can check on the legacy Reverge PM10. Also, we introduced this technology onto the CLQL mixing console. So the final page, you can see the which products have which technology. So channel strip equalizer from Reverge PM10 goes to firmware update for the CLQL version 4. The bus compression 369 goes to the firmware update for CLQL version 3, kind of things. So nowadays, Reverge PM10 has great analog sound technology in the digital domain, and also the CLQL newer updation firmware being introduced. Very goodness of the analog sound on the Reverge PM10. Thank you. Have any question about our technology?
Hi, I just have a question about the emulation technology. You showed the LA2A, and LA2A is basically modeled by many brands.
Many what's
Brands, different companies. Like UAD has done it, Waves has done it. So lots of different companies have emulated the LA2A, the 1176, all the classic compressors. So like, what's the difference in terms of like the VCM approach versus whatever the other companies are doing? Like some might use modeling, some might use impulse response. So how is VCM different from what Waves might provide or what Universal Audio might provide? That's one question I have.
okay?
Yeah.
So can I confirm your question? So LA2A emulation, many audio vendors realize that. Universal Audio has emulation, or maybe Waves also have, or other blah 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 blah. So, what is the difference between them, and what is the strength of Yamaha? Okay, so I don't want to say bad words for the other industry, but actually they are not enough. That's all I can say. So I talk about the mathematics things, we are applying very good and better mathematics to describe the digital analog sound in digital domain, as I showed you in this PowerPoint presentation. Also, when we talk about the particular technology like opto-compression, people usually think this is a gain reduction device, so the laser level, so reduction will happen. That's all. But we know that opto device has a very long response, like 30 seconds or 1 minute or 2 minutes. We did that using VCM technology. And not only the impulse response emulation technology, more sophisticated individual technology should apply when we talk about the individual gears. Because, when we talk about the impulse response combination, like Focusrite things, the impulse response is just a static frequency magnitude response things. But the dynamic thing is more important than not only that the frequency band control. But the impulse response technology cannot treat this kind of delicate and very difficult modeling things. So finally, general technology like impulse response convolution morphing or something like that, I don't know the correct terminology they applied. Those technologies are older age technology. So if we are very serious about music and the gears also, we have to be very honest, and we have to learn and study and investigate, pursue about the original circuit diagram and devices both. None of the general technology cannot apply them to the serious emulation. Serious emulation always will happen when we analyze the circuit diagram, analyze the component level things. This is the, I can tell you. The another things I can stress today is how we tweak the parameter is very important. So if I can show you the standard, our development procedure, not only the mathematics and the DSP coding, but also the tweaks of the parameter, listening session and the tweak the parameter, listening session, tweak the parameter. This is very important, and the same kind of amount of time period we consume. Usually the other vendors thrash this, not only the math and the DSP model, boom. But that's not enough. We have to tweak the parameter to get the same kind of the musical quality of the original gears, because this is the expectation of the customers, right? It's enough?
Yeah, thank you. Can I ask one more question, please? Yeah, so one more question I have is about the bit depth, the processing bit depth. The word length, the processing word length. Originally it was like 32-bit, then it became 40, 48-bit. Now lots of software are allowing 64-bit processing. And what I have heard is that basically, the ability to differentiate between the analog hardware and the plug-in emulation also is maybe because of the bit depth of the processing. And the bigger the bit depth, the deeper you go, the more difficult it becomes to differentiate between the original hardware and the plug-in. So does Yamaha operate at a particular processing bit depth, 48-bit or 64-bit or something like that? And will we need to go even higher? Like, will we require 128-bit in the future or something like that? Maybe we might reach a point where nobody can tell the difference between the hardware and the digital version. So I just want your thoughts on this.
So basically, your question is how we can utilize the bit weights of the calculation in the DSP or CPU wise, and what is my expectation or estimation? Okay, so it's a very tough question because we use many kind of the calculation methods. For example, sometimes we apply the 64-bit bit floating point arithmetic. In many cases, 32-bit is enough. And if we talk about the integer calculation scheme, so sometimes we apply the 48 or 64-bit integer processing also. And in many cases, we are very famous on our proprietary DSP chips. We can make the specialized DSP chip for our console. We are hardware vendor, and we are software vendor, and we are semiconductor vendor. So we can make many things. And in some cases, like this kind of VCM stuff, so we apply the 40-bit arithmetic using analog device incorporation structure. So I talk a lot, we have so many choice on the arithmetic things. And most important things is appropriate choice is very important. In many cases, 8-bit is enough if we think about the VMator display. But the audio things, 32-bit is necessary minimum requirements. I can say yes. But anyway, not only the choice of the floating point or integer arithmetic, but also the bit width is very important. And what kind of things we emulate now, this is the most key issue. So I cannot tell you this is good. Many things can be good. And we do appropriate choice. That's all I can tell you. So bigger is enough. So bigger is good. But sometimes smaller things can be good choice, good solution for us. So no, more things better, but I cannot tell you this is the best one because it's, individual cases, it's up to the cases. Is it good for you?
Yeah, thank you. Thanks a lot.
Thank you.
The Palm Show is not just a huge exhibition with all the equipment there. I want to thank Yamaha, who have sponsored this conference, and we are grateful to Yamaha for doing this. Thank you very much.